Hello everyone. So today I, Swati Verma, Assistant Professor at Calcutta's University, School of Medical and Allied Sciences, Department of Pharmacy, shall be discussing with you about thin layer chromatography, that is TLC. So we will discuss about what is TLC, what is the basic principle behind its operation, and what its basic instrumentation parts. So moving forward, first thing we need to talk about is your history. So in 1938, Ismailov and Shabier separated plant extracts using 2 mm thick film layer of alumina set on a glass plate. So first it was used in 1938 by Ismailov and Shabier, who had separated plant extracts. In 1953, Krishner identified terpenes on filter paper. So the first identification was performed by Krishner in 1915, and he identified terpenes on filter paper and later glass fiber plate coated with alumina. In 1958, Stahl developed standard equipment for analyzing TLC. So first equipment was developed by Stahl in 1958. Okay, so the basic principle is your adsorption. So what will happen in case of adsorption? Whenever a mixture of components you will place on your adsorbent, that is your silica gel, and you will put that particular plate into the mobile phase. So what will happen? Your components will show their RF value will move according to their relative affinity. Like the component who is having more affinity towards your mobile phase will move faster, whereas the component who is having less affinity towards your mobile phase or having more affinity towards your stationary phase will move slower, and hence your component will get separated depending upon their relative affinities. So the mixture of compounds are spotted on thin layer of adsorbent coated on a chromatographic plate. This particular chromatographic plate is made up of glass. The mobile phase solvent flows through because of capillary action, and it is against gravitational force. The components will move according to their relative affinities towards adsorbent. The component with your more affinity towards a stationary phase travels slower. The component with lesser affinity towards a stationary phase travels faster, and hence the components are separated on a TLC plate. So the component having more relative affinity towards a stationary phase will travel slower, and the component with lesser affinity towards stationary phase or higher affinity towards mobile phase will travel faster. Next is your advantages of TLC. So what are the basic advantages of TLC? First is your sample preparation is usually relatively simple. Sample can be directly compared, often they are running. So if we are having multiple samples, we have multiple TLC chambers and different components are there. So we can just judge them, we can compare them easily by just looking to your TLC plate. Parallel development of related and unrelated samples can be carried out simultaneously. A range of detection procedures can be applied, often to the same plate. So over the same plate, whenever we are going to detect our sample, so we can apply different types of detecting agent that can be a specific or non-specific. The separation can be followed throughout the whole process and stopped when derived or when the solvent system changed. Solvent and other reagents are required in very small volumes. So we do not require your bulk solvent, just your solvents and reagents quantity need to be very small. Next, it is a rapid technique and not time consuming. Detection is easy and it is not that much tedious, quite simple. Simple method and cost of equipment is low. Corrosive spray reagents can be used without damaging the plate. So you can use corrosive spray reagent As we are developing this particular technique over glass, so chances to damage the plate is lesser. In case of TLC, the stationary phase consists of a thin layer of sorbent, which can be a silica gel, cellulose powder, or alumina, and it is coated on an inert rigid backing material such as glass plate, aluminium foil, or plastic foil. As a result, the separation process takes place on a flat surface. The particle size of the silica gel for TLC is 10 to the power 40 micrometer. So the particle size is 10 to the power 40 micrometer. The average particle size is 15 micrometer. Now these are your certain examples of materials which you can use for your TLC. These are your coating substances that you can use, the solvent system and the mechanism of separation. Like silica alumina, if we are having as a coating substance, so the solvent system that you can use can be a chloroform, methanol, toluene, acetone. The method of separation is adsorption. Second one, your diamino ethyl cellulose. Your solvent system is 0.1 molar aqueous NaCl. Your mechanism of separation is ion exchange. Then you can have cellulose or silica. The solvent system that you can use is butane 1-ol, acetic acid, water in a ratio of 4:1:5. The mechanism of separation is partition. Then you can have paraffin oil or silicon oil. The solvent system is acetic acid and water. The mechanism of separation is reverse phase partition. The coating substance you can have Cefadex G. Your solvent system is aqueous buffer and your mechanism of separation is molecular separation. Then these are your certain practical requirements. Like first, what you need to run a proper TLC. You need a stationary phase, then glass plates, preparation and activation of TLC plates, application of sample, development chamber, mobile phase, development technique, detecting or visualizing agent. So these are all your basic requirements that you need to have if you want to run any TLC. So first is your stationary phases. So stationary phases are the range of substances which are now available for use as a stationary phase in TLC, which extends far beyond the traditional silica gel and alumina. Silica gel is commonly used and it is now available in numerous particle sizes and mixed with a variety of binders such as calcium sulfate, which may also incorporate your fluorescent indicators. Similar combinations also occur with alumina, which can be tried to give various levels of activation. So-called reverse phase materials are also available for use with aqueous eluents. In case of reverse phase materials, we have generally your octadecyl silane. These consist of long chain hydrocarbon bonds like C10, C18, which have been bonded with silica gel via the hydroxyl groups. So adsorbent that can be mainly used are your alumina, silica gel and Kieselguhr. Your types of adsorbent can be inorganic and organic. So the adsorbent that we are having generally fall into categories. Either they are inorganic in nature or they are organic in nature. So here I listed certain inorganic and organic adsorbents. Like in inorganic, we can have alumina, aluminium silicate. So aluminium silicate we can use for separation of esterols and esterol glycoside. You can have bauxite for the separation of carbohydrates. Calcium carbonate for separation of xanthophylls and other pigments. Calcium silicate for separation of carbohydrates. Kieselguhr, silica gel for separation of esterols, glycerides, fatty acid, amino acids and sugar acetates. Then you can have organic. In organic we can have cellulose, polyamide, flavonoids, sucrose and dextran cells. Then you can have glass plates like full plate 20 by 20, half plate 20 by 10, quarter plate 20 into 5 centimeters. So these are certain dimensions. You can have either full plate, half plate and quarter plate. This is your length and this is your width. These dimensions are used since the width of the commercial available TLC spreader is 20 centimeter. Microscopic slides can also be used for your separation purpose. Glass plates of different dimensions can also be used, and generally for pouring we can use TLC spreader. So these are your certain references, the names of the book that you can refer for TLC. Thank you so much.